Hello, hi dear students, welcome to my channel Maths with Panindra. In this video, we are going to discuss the basic geometry concepts which are related to the 10th class as well as intermediate first year. Most of the students requested to me, so give that minimum knowledge about basic geometry. So that is the reason I am making the video. So let us have a discussion. So prerequisites of 2D geometry. So in this 2D geometry, first we have to know about the coordinate system. In this coordinate system, we need to discuss about x-axis, y-axis, origin. After that, how to represent the point in the plane. How to represent the point accordingly, the quadrants. So these information I am going to discuss. After that, simultaneously we will discuss the respective concepts. See here, first coordinate system. What is meant by coordinate system? Let us consider two mutually perpendicular lines x dash x and y dash y. X dash y dash are two mutually perpendicular lines. The line x dash x and is called horizontal line. The line x dash x is called horizontal line, and the line y dash y is called vertical line. So y dash y, x dash x is called horizontal line. This is horizontal line. Y dash y is called vertical line. This is called vertical line. This is vertical line. This is horizontal line. It indicates the meeting. These lines are called coordinate axes. The horizontal line as well as vertical line. These lines are called coordinate axes. You have to remember, this is very important one. Coordinate axis. Once again I will repeat. The line x dash x is called horizontal line. Horizontal line is this one. And y dash y is called vertical line. This is vertical line. These lines, horizontal line as well as vertical line, are called coordinate axes. These two are called coordinate axes. After knowing the coordinate axis, the meeting point of x dash x and y dash y is called origin. X dash x is horizontal line, y dash y is called vertical line. The meeting point of these two, x dash and y dash, is called origin, which is denoted by 0, 0, which is denoted by O, and it is defined as 0, 0. You remember, this is called origin. The meeting point of x dash x and y dash y is called origin, and it is denoted by capital O, and it is defined as 0, 0. After completing of the concept of origin, now x dash OX is called x-axis. Previously, origin is not there. Only x dash x is called horizontal line. Y dash y is called vertical line. Whenever these two lines which are intersecting or meeting at the point O, then it is called origin. Now, x dash OX is called x-axis. This is called x-axis. This one is called x-axis. Similarly, y dash OY or y dash is called y-axis. This is called y-axis. X-axis and y-axis. X dash OX is called x-axis. Y dash or y dash OY is called y-axis. X-axis and y-axis. the x-axis, y-axis and origin is called coordinate system. If anyone will ask what is coordinate system, the combination of x-axis, y-axis and origin, x-axis, y-axis and origin is called coordinate system. So in this coordinate system, what terms we learned? We learned horizontal line, vertical line, coordinate axis, origin, x-axis, y-axis, after that coordinate system. This is the information about the coordinate system. Now let us move to the representation of a point in the plane. Every pair of real numbers x, y determine a point in the plane. It is represented by open interval of x, y. That means open parenthesis and closed parenthesis. X, y. This is the representation of a point in the plane. Every pair of real numbers x, y determine a point in the plane. It is denoted by open parenthesis and closed parenthesis of x, y. In this x, y, in this open interval of x, y or open parenthesis and closed parenthesis x, y, where x is called x coordinate, in brackets x suffix p, xp, and y is called y coordinate, in brackets yp, y suffix p, of a point. So here x is called x coordinate of the point P, y is called y coordinate of the point P. Another name for x coordinate and y coordinate is x coordinate is called abscissa and y coordinate is called ordinate of the point. Ordinate of the point. Another names for x coordinate and y coordinate. Now let xp denote the perpendicular distance of p from y axis. See, observe this figure. This is the point in the plane p of x, y. The distance from point P to the x-axis is mod yp. So yp denotes the perpendicular distance of P from x-axis. So from here to here distance denotes always yp. In the same way, xp denotes the perpendicular distance from point P to the y-axis. So wherever mod x, otherwise sometimes we can denote yp as mod y. The distance from point P to the x-axis is always equal to mod y. Even here also. That is, we can write it here. That is, we can write it. xp denote the perpendicular distance from point P to the y-axis is mod x. Here also, the perpendicular distance from yp denotes the perpendicular distance of a point P from x-axis is mod y. Even like this also you can write it. Here also I represent yp is mod y, xp is mod x. So clearly we can get it information. The distance from a point P to the x-axis is mod y. The distance of a point P which is from y-axis is mod x. After that, the coordinate axis divide the plane into 4 equal parts. This is the coordinate system. Coordinate axis x, o, x is x-axis, y, o, y dash is y-axis. This, the coordinate axis, that means x-axis and y-axis, which divides the plane into 4 equal parts. Each equal part is called quadrant. This is the first part, second part, third part, fourth part. So Q1, Q2, Q3, Q4. Each part is called quadrant. Each part is called quadrant. Here, I will highlight that. Each part is called quadrant. If you observe that, the regions in this figure, X, O, Y, it is Q1, quadrant 1. Y, O, X dash, it is quadrant 2. X dash, O, Y dash, quadrant 3. Y dash, O, X, quadrant 4. So how to represent the point in the plane with respect to these 4 coordinates, that also we are going to discuss. The regions x, o, y and y, o, x dash, o, y dash and y dash, o, x are quadrants Q1, Q2, Q3 and Q4. In these quadrants, how to represent the point in the plane related to the quadrant. See here, observe this figure. The point P of x comma y, which is belongs to first quadrant. In the first quadrant, both x and y coordinates will be greater than 0. Both should be positive. So x is greater than 0, y is greater than 0. Therefore, the position of a point in the quadrant 1, Q1 is P of x and y, x comma y, both are positive. Here I will represent plus plus. In the Q1 point, x coordinate and y coordinate should be positive. Come to the second quadrant. The point P represent in the quadrant 2, second quadrant. X is less than 0, y is greater than 0. That is the reason the point should be in the form of minus and plus. Minus and plus. X is less than 0 means minus. Y is greater than 0 means plus. Similarly, come to the third point, third quadrant. The point which belongs to third quadrant, Q3, both x is less than 0 as well as y is less than 0. X is less than 0, y is less than 0. Therefore, the point is on the form P of minus x comma minus y. Both x and y coordinates should be negative. Come to the fourth quadrant, P of x comma minus y. In this fourth quadrant, x is positive, y is negative, negative direction. It is negative direction, this is positive direction. So x is greater than 0, y is less than 0. So it is P of plus minus. The point in the form of plus minus is, the point is belongs to quadrant 4. For example, minus 2 comma minus 3. This point is belongs to which quadrant? Minus 2, minus 3. Both quadrants are, both x coordinate and y coordinates are negative. So both negative, both less than 0, in which quadrant it is possible? In quadrant 3. That means the point minus 2 comma minus 3 which belongs to Q3. In the same way, 1 comma 0, 1 comma 2. So both are positive. Both are positive in which quadrant? In the first quadrant. So 3 comma minus 2. X is greater than 0. 3 comma minus 2. X is equal to 3. So it is greater than 0. Minus 2. Y is equal to minus 2 less than 0. X is greater than 0. Y is less than 0. In the fourth quadrant it is possible. Therefore, 3 comma minus 2 which belongs to fourth quadrant. In the same way, if we take the point is related to the quadrant 2, minus 2 comma 3, x is equal to minus 2 which is less than 0 and y is equal to 3 which is greater than 0. Therefore, the point P of minus 2 comma 3 belongs to quadrant 2. This is the way the point represented in the plane according to the quadrant. Let us move to the another concept. The next concept, distance between the 2 points in the plane. How to calculate the distance between 2 points in the plane. So consider 2 points in the plane. See here how we are going to x-axis, y-axis. This is negative x-axis, negative y-axis. This is origin. I am considering the point here A of x1, y1. The point is first point now, A of x1, y1. That means the distance from a point A to the x-axis is, we know that it is equal to y1, y coordinate, y1 here. The distance from y-axis to the point is x1. So from here to here, how much distance is there? From here to here is also same distance now. Here I am taking as m. So OM is equal to x1. Obviously here also some point you take m. NA is also x1. Similarly, you consider another point in the plane. This I am taking B of x2, y2. That means the distance from a point B to the x-axis is y2 units. So it is y2 from here to here. Similarly, here some take the point P. From here to here, the distance from a point B to the y-axis is x units. X means what here? x2. From here to here, x2. Here I am taking some q. So BQ is equal to x2 means obviously PO is also x2. From here to here it is x2. From here to here x1. This value, PM value is equal to what? x2 minus x1. x2 minus x1. PM equal to OP minus OM. From here, PM is equal to OP minus OM. OP means x2 minus OM means x1. So that is PM. Similarly, from here to here it is y2 now. The distance from point B to the x-axis is y2. So the distance from point Q to the y is also from N to O, the distance is y1. From Q to O, the distance is y2. So the distance from Q to N is y2 minus y1. So whenever this distance is same, if you join like this, here some point to take some C. Even Qn is equal to BC, this value is also y2 minus y1. Now join these points. Join A and B. So here it is absolutely right angled triangle. I want to calculate the distance between A and B points. So from here, BC value is y2 minus y1 and MP is equal to AC. So from here to here is also x2 minus x1. This is y2 minus y1, BC value. From here to here, it is y2 minus y1. So triangle ABC is right angled triangle. Right angled triangle. Whenever it is right angled triangle, it follows Pythagoras theorem. So Pythagoras theorem is according to that. AB square is equal to hypotenuse square equal to sum of the squares of the remaining sides. AC square plus CB square or BC square. So AB square is equal to, AB square means what? Distance between these two square. AC square, AC means what? x2 minus x1 whole square plus CB, CB means what? y2 minus y1 whole square. But I want only AB. So if you remove that square here, it will become the square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the distance between 2 points in the plane. The distance between 2 points in the plane. AB equal to x2 minus root of. This also we can define like this way. That is, we can define as AB is equal to distance between A point and B point is square root of difference of x coordinates. Difference of x coordinates whole square plus difference of y coordinates. We can define like this also. Sum of the squares of difference of x coordinates and difference of y coordinates. After knowing that distance between 2 points, one important corollary is there. The distance from any point in the plane to the origin See here how it will be. X-axis, y-axis. This is the origin. Here I am taking the point P of x comma y. The distance from point P to the x-axis is y or mod y. The distance from point P to the y-axis is x. So obviously from here to is also x. Why? Because these two are equal. So here some take Pm, here key n you can take. So ON is also equal to y and Pn is equal to OM. I want distance between these 2 points. Origin to. If you want to apply this formula, you can apply. Otherwise, Pythagoras theorem also you can apply. So note, the distance from a point P of x comma y to the origin. The distance from a point P to the origin. Is OP equal to. First, you have to apply Pythagoras theorem and another formula also given. So by using from triangle OPM, OP square is equal to ON square plus PM square. So I want only OP. OP is equal to square root of OM square plus PM square. So OP is equal to square root of OM. What is OM? X square plus PM. PM is what? Y square. So now onwards you remember the distance from origin to the point in the plane or the distance from a point P to the origin is always equal to square root of x square plus y square. For example, the distance from a point P to the, find the distance, like this example they will give. Find the distance from minus 5 comma 3 to the origin. So whenever the distance from origin to the point means the given point you take as x comma y, given point P of minus 5 comma 3 irrespective of negative or positive x comma y. So the distance from origin to P is OP equal to square root of x square plus y square. So which is also equal to root of minus 5 whole square to the 5. I will write step by step. Plus 3 square. Root of 25 plus 9 which is equal to root 34. This is the way you can apply. Even here also we will take 2 points and find the distance between them. We will go to the another concept. The next concept is section formula. In this section formula, internal and external division. Division formula or section formula. Observe the first case. Here a of x1 y1, b of x2 y2. Here I am considering one point P of x comma y. The point P divides in the ratio m is to n internally. This is internal division. How we can say that the division is internal? Whenever the dividing point, the division point P in between A and B, that means it is not midpoint, in between A and B. See here, the point P is here, the line joining the points A and B. The line segment joining A of x1, y1, B of x2, y2 divides by the point P of x, y in the ratio of m:n internally. How to calculate the coordinates? Simple one. The coordinates of P divides the line segment joining the points A of x1, y1 and B of x2, y2 in the ratio m:n internally means, you remember, the point P is in between A and B. So the coordinates I am writing here, P of x, y is equal to, how to remember this formula in easy way? Internally I am writing m into x coordinate here, mx2 plus, internally means plus, n into x1 divided by m plus n. So which is equal to mx2 plus nx1 divided by m plus n. Similarly for y coordinate, my2 plus ny1 divided by m plus n. my2 plus ny1 divided by n plus n. This is internal division point. Similarly, external division also we will discuss. Here only I will explain. Yeah, the next point here, external division. Internal division is over. I think this is the first one, the coordinates. Here also second one I am going to do that. The coordinates of P divides the line segment. Here the point is A, the point is B, the point is P here. So A of x1, y1, B of x2, y2. This external division we can do in the two cases. We can get two cases. How it is, I will explain now. The point P is x, y. So observe carefully. I will give the direction here. External division means we are getting some directions. So P divides AB in the ratio. P is dividing now. So A to P direction, this is positive direction, so positive. And here again from P to B, it is negative direction. In internal division, this ratio m is to n, that means m by n is greater than 0. In the internal division, m is to n is, that is m by n is greater than 0. If we come to external division, m is to n, that is equal to m by n is less than 0. This is for external division, that is for internal division. So here according to the direction, from here to here it is m units, from here to here it is n units. So whenever the direction is changing, this is positive direction, this is negative direction. That is the reason m is positive, n is negative. So positive by negative, which is equal to negative. So negative is less than 0. So not only this case, but also we can take like this also. You observe one blind notation. Whenever it is external division, the point P divides the line segment AB in the ratio of m is to n externally. The point P is away from A and B. If it is internal, in between A and B, but it is not midpoint. Away from A and B in the external case. It may be like this also. The P point will be here, P of x comma y, and A of x1 y1, B of x2 y2. So now the point P divides AB. I will give like this direction. So AB, this is negative direction. After that PB, this is positive direction. So from here to here it is negative direction. That is the reason minus I am going to get. M value is negative. From here to here it is n units. So positive. In this case, m is positive, n is negative. That is the reason in these two cases in external division, either this case or this case, m is to n ratio will be less than 0. So that is the reason we are going to get here. The point is wherever plus is there, we are getting minus. So the coordinates of P divides the line segment joining the points A of x1 y1 and B of x2 y2 sorry, in the ratio m is to n externally is whenever we are getting the term externally, wherever here plus is there, we have to replace with minus. So P of x comma y, the coordinates of P, is equal to mx2 minus reverse direction n into x1. So mx2 minus nx1 divided by m minus n. I think everyone understand. I hope everyone understand. Why? Because mx2 means this is positive direction minus. Why we are taking minus? From P to B, that it is traveling opposite direction, negative direction. So that is the reason minus nx1 comma. Similarly, y coordinate also my2 minus ny1. my2 minus ny1 divided by m minus n. So these are, in this case m by n is less than 0, in this case m by n is greater than 0. Especially incident JA people, you have to remember this formula. We will move to the next concept. The next concept, coordinates of midpoint of the line segment AB. Coordinates of midpoint of the line segment AB. See here, A of x1 y1, B of x2 y2. So here P is the midpoint. Midpoint means from here to this point and from here to this point is equal distance. We know that the point P divides AB in the ratio of m is to n. You will get the coordinates of P will becomes P of x comma y equal to, if it is m is to n, what we are getting, mx2 plus mx1 divided by m plus n, my2 plus ny1 divided by m plus n. If the point P divides the line segment AB in the ratio of m is to n. Whenever you are going to calculate midpoint of the line segment, from here to here distance should be equal to from here to here. That means m is equal to n. This value substitute in this case to get the midpoint. Why midpoint? From here to here distance should be equal to from here to here. So m is equal to n. If you substitute there, mx2 plus mx1 divided by m plus m, my2 plus my1 divided by m plus m. So which is equal to m take common, m into x2 plus x1 divided by m plus m is 2m, m take common y2 plus y1 divided by 2m. So here m get cancelled, here m, here get cancelled. x2 plus x1 divided by 2, y2 plus y1 divided by 2. These are the coordinates of midpoint. Therefore, the midpoint of the line segment a of x1 y1 and b of x2 y2 is p of x comma y, x2 plus x1 by 2 comma y2 plus y1 by 2. This is about the midpoint of the line segment. Whenever you are calculating the midpoint, so from here to here distance should be equal to here to here distance. This is the midpoint coordinates. Therefore, the midpoint of the line segment AB. So midpoint of A of x1 y1 b of x2 y2 is x2 plus x1 by 2 comma y2 minus y2 plus y1 by 2. In other words, we can write it as midpoint of AB is equal to sum of the x coordinates by 2 comma sum of y coordinates. So we can write like this also. x2 plus x1 by 2 is sum of the x coordinates by 2. y2 plus y1 by 2 sum of the y coordinates by 2. In other words, we can write like this. So this is also midpoint of AB. We will move to the points of trisection in this concept. Points of trisection. The next concept is points of trisection. So the point which divides the line segment AB in the ratio of 1:2 or 2:1. See here, the figure will come like this. A of x1 y1 and b of x2 y2. So the point P is here. This point P divides the line segment in the ratio of 1:2 or A of x1 y1 b of x2 y2. The point is here. This point P divides the line segment AB in the ratio of 2:1 internally. Then these two are called points of trisection. The point P which divides the line segment AB in the ratio 1:2 and 2:1 is called points of trisection. One internally is is called points of trisection. Points of trisection. See here, come to the point. Suppose if you come to this figure, from this figure, the point will becomes P of x comma y. Which divides according to this figure. This is m, this is n. So nx2 means 1 into x2 plus 2 into x1 divided by 1 plus 2 comma 1 into y2 plus 2 into y1 divided by 1 plus 2. That means x2 plus 2x1 divided by 3 comma y2 plus 2y1 divided by 2 plus 1 3. So this point P of x comma y divides the line segment joining 1:2 internally is called points of trisection. Not only this case but also 2:1 is there. How to get it? The point P of x comma y, again you have to apply the point 2 into mx2, 2 into x2 plus 1 into x1 divided by m plus n, 2 into y2 plus 1 into y1 divided by 2 plus 1, which is equal to 2x2 plus x1 divided by 3, 2y2 plus y1 divided by 3. So this is P of x comma y. This is also points of trisection. So here or we don't know. Here also we can write it as or itself. 2:1 or 1:2. So any of them. Sometimes they will ask in the competitive exam, both the points they will ask. Find the points of trisection of these two. A of x1, y1, b of x2. So these two are points of trisection. In the options they will give both them. We will discuss some questions related to these concepts in the coming classes. And some important points which will use in the middle of the problems that I will explain now. Some little concepts. Some important notes we are discussing here. The line segment joining A and B denoted by AB. That means ends are there. Line segment means like this ends will be there. So there is no extension there. So from here to here, particularly from A to B, that is the line segment. There is no extension from right side or left side. These are the ends of the line segment. So the line segment is denoted by like this, AB. Next, the ray from A through the B by denoted by AB. That means the initial point is A and it is passing through the point B. It is having the ray. So there is no end at all. This is the initial point, initial position A. There is no end at all. It is this ray is passing through the point B. It is called the ray. AB ray. This is line segment. Line segment. Similarly, the straight line passing through the point A and B by AB. Both sides arrow mark means there is no end at all. So here A point, here B point. This is a straight line. Simply I am writing a ST line, straight line. There is no ends at all. From this side or this side, there is no end at all. It's a straight line. This is the difference between line segment, ray and straight lines. We will discuss another concept like points of trisection we have completed now. So after that we will enter into the area of triangle, the area of quadrilateral. Like these concepts we will discuss. Now, the ratio in which the point x, y divides the line joining of x1, y1 and x2, y2. In the ratio, this concept is very important, dear students. See here, this is the line joining x1, y1, b of x2, y2. The point in which, this is the point here, p of x, y. The point, it divides the line segment joining these points in the ratio, see, easy to remember, x1 minus x is to x minus x2. x1 minus x is to x minus x2, or wherever x is there, y you have to replace. y1 minus y is to y minus y2. So what you have to write here? The ratio in which the point p of x, y divides the line segment joining a of x1, y1 and b of x2, y2 is x1 minus x is to x minus x2, or y1 minus y is to y minus y2. After knowing of this concept, we have two sub cases. See how it is. The sub cases. So point 1. Suppose this line joining points divides by x-axis. I will draw the figure. A of x1, y1, b of x2, y2. First I will take y-axis, easy to understand. This is the y-axis. That means y-axis divides the line joining of points. Y-axis divides the line joining points a of x1, y1 and b of x2, y2 in the ratio whenever y-axis means minus x1 is to x2. Sir, how it will come minus x1 is to x2? See here, y-axis means what? The equation of y-axis is x is equal to 0. X is equal to 0, substitute in this. You will get x1 is to minus x2. x1 is to minus x2 means what? x1 by minus x2. So, negative value cannot be put in the denominator. So, minus x1 by x2 we can write it in the ratio minus x1 is to x2. Now onwards, you remember the y-axis divides the line joining of these points in the ratio minus x1 is to x2. Number of times based on this concept asked in the exams, competitive exams. Now come to the second point, like x-axis. X-axis divides, that means the line joining points you are taking as like this. A of x1, y1, B of x2, y2. This is x-axis. X-axis divides the line joining of A of x1, y1, B of x2, y2. X-axis divides the line joining points, the line joining points A of x1, y1 and B of x2, y2 in the ratio. X-axis means y equal to 0. So y is equal to 0, substitute in this. y1 is to minus y2. That also can be written as minus y1 is to y2. So these two important points you have to keep in mind. This is very important. Based on this, we will discuss number of questions. Y-axis, x-axis. This is the way they will ask the points. These are the very, very important points. We will move to the next one. The next concept, harmonic conjugate. The 2 points P and Q divides the line joining of x1, y1 and x2, y2 in the ratio m is to n internally and externally. Then P is called harmonic conjugate of Q. Then P is called harmonic conjugate of Q. See how the figure will be. This is the line joining of A and B. Observe carefully. This point P divides the line joining in the ratio m is to n internally. Internally means the point P should be in between A and B. But it is not midpoint. P divides AB in the ratio of m is to n internally, and Q it divides m is to n externally. So externally means the point should be here. Q is away from A comma B. So therefore this P is called harmonic conjugate of Q, or Q is harmonic conjugate of P, vice versa it is. This is about harmonic conjugate. One more important result I will discuss related to the harmonic conjugate. Even in the progressions also we know that harmonic progression like this. So even by using that concept also we can see harmonic conjugate. ABC are in harmonic progression means what? 2 by B equal to 1 by A plus 1 by C. In the same way, here the points P and Q which divides the line segment A and B, we are taking as this is A, this is B. No? So how to write these? Here this P point, Q point also I am writing here P and Q. So 2 by AB is equal to 1 by AP plus 1 by AQ. This is the ratio. Like this we can calculate. This is also harmonic conjugate. To get either P value or Q value, we can use from this harmonic conjugate. We will discuss the problems based on these concepts. Whatever I am discussing here, all basic points, we will discuss in the next video, the problems related to harmonic conjugate. Yeah. Thank you, dear students, for watching my channel. In the next video, collinear points, condition for the collinearity, area of triangle, area of quadrilateral with shortcut tricks and all we will discuss in the coming video. Thank you all for supporting Maths with Panindra.